Okay, let's go ahead and get started with Chapter 5, Data and Process Modeling. I had you do DFDs, data flow diagrams, last chapter. That chapter really wasn't specific. This chapter is very specific, but again, I'm looking for rudimentary on this, not anything elaborate. I'm going to have you do something a little different this time, and you'll see as you get down to that of what I would like you to do. But again, this chapter is quite elaborate in data flow diagrams, and I purposely had you do a simple one last chapter in order to not tie up and make anything very complicated and intricate. So you can see the objectives as we go through here. A couple things, I'll start with this and then I'll end with this: logical models and physical models. Anytime that this really applies to areas, or this can apply to areas outside of design. For instance, telecommunications. If I was designing a network, I would do a logical model, which means I would put one system up, maybe show some address schemes for that, and then kind of get an idea of how I'm going to lay things out. And then when I do an actual lay the network out, I would show each computer, each line, each everything that comes out. So that's really what I spend a lot of time on doing when I teach networking. But we will go through and do DFDs in a little more in depth this time. Again, data flow shows how data moves through an information system. You can do a logical, you can do a physical. We'll spend a lot of time on logic this time. The symbols that we use, and I don't expect you to unless you've already read this chapter, go back and try to correct anything. I didn't really care what your symbols look like, but if you are doing symbols, a true DFD would look like this and what you were laying out, depending on the, whether it's a process or whether it is a flow rate, an entity, or whatever you're going to be using. I won't talk a lot about entities, that's mainly database talk, but please note that they do exist. The process symbol, again, you can look and read this. I'll pause here for just a second. Make sure when you're doing a DFD you have an input and they have an output. Then you have an action in between those two, or a process on what you're actually doing. This seems very rudimentary. I understand that, but I'd like you to really understand that you need to be basic in this. The complexity can come afterwards, but basic starting off right now. Here's the symbols at work. Services performed, you create an invoice. Work submitted, you grade the work, and then students get a grade. So again, just reiterating what we're trying to do. Again, more of these. Entities. Entity can be take the place of a noun. A person, place, or thing can be an entity. It's typically not used as an action or any kind of process. It's something that a process takes place to, or with, or for. Again, the diagrams. Hope you can see the customer applying the payment. What happens on this? Now look over here at the incorrect and see payroll department paycheck to the employee. Well, why would that be incorrect? Let's pause here and let's park here for just a minute. Because the payroll department would not go through a process. It would just issue a paycheck to an employee. But notice how it's not engaged in any of this over here. So flow lines must be labeled. Again, bidirectional, unidirectional. Will most of them be bidirectional? No, they won't. Most of them will be unidirectional and have a feedback loop. Creating a set of DFDs. See the process right here for doing this. Make sure it fits on one page. Even if it's, again, a logical diagram, you want something simplistic. Excuse me. You want something simplistic, something labeled out here. Use the name of the information system as a process name. Don't cross lines. Don't make it complex. Keep things simple and keep it organized. Move it around. Don't put out the first thing you come up with. Drawing the diagram. What happens to the order system right here? How does it get when the customer makes an order? How does it get to the customer? You know, when it comes back out, it goes to the warehouse. How does this work? Now, this seems real simple. Be careful, because sometimes companies don't do this, and I've always been amazed at how things can be so simple, and companies can't quite make all of this happen. But this needs to be done in order for the information systems to work properly. Diagram 0. Your book explains this quite well. I won't try to reiterate. Note that there is a parent diagram and a child diagram. Lower level diagrams and trying to fill an order. Again, the customer makes an order. How does it get to the warehouse to go out to the customer? Now, the leveling and balancing technique, this is interesting, because if this is not leveled and balanced, then what happens if you take too many orders and you're not able to process the orders? Well, it's happened to companies. Companies have gone under. Kmart is an example of a company that has taken too many orders, did not have a supply chain management system in place, and they were not able to deliver the customer's order. People would go to, if you read the history behind the failure of Kmart, people would go in and on a sale day and try to get the item. The item wasn't in. I've noticed that myself back when I shopped at Kmart. I noticed that when something would go on sale, I would go get it. She said, the lady would say, they haven't come in yet. So here you are having an item for sale without the item in stock. This is caused by not having leveling and balancing in DFD, data flow diagrams. More modeling techniques. Take the process right here. Exploded. This is what happens inside the process. Data dictionary is just that. It defines what something is. You have to know the facts about a system, because depending on where in the country you live or where in the world that you live, different things mean different. Different people have different understandings about certain terms. You mention one term to a person from the West Coast, and then you mention that same term to someone from the East Coast, or even that is outside of the U.S., then you'll have a problem. It means different things. So a data dictionary actually describes and defines elements. We're approaching a database right here with a data element and a record. If I was to define this, I would say that if I was to tell you about an element, I would say that you all, each of you all are unique. Students are unique. What makes you unique is not your name. It's because some students have exactly the same name. I've had students in my class with exactly the same name, same first name, same last name. Different people, not related. So you have an 800 number. If you're at Western, you have an 800 number that defines and gives you a specific unique element in your record. So in your record, if you all have, if you list this out in your record, you have your first name, last name, address, city, state, zip, blah, blah, blah. all of that can be the same. For instance, that could be identical except for one thing. Your 800 number would be the differences for that. I'm not going to spend time on case tools or talking about the data elements. Documenting the data elements, this needs to be listed someplace. It usually falls apart at this stage for companies because records are incomplete. If you noticed on this data dictionary right here, the Social Security number is the unique item. Everyone in the U.S. has a unique Social Security number. If you've registered with Social Security Services, no two numbers can be given out that are identical. Documenting the data flows. We've talked about data flow a lot in here. In this dictionary talks about the data store named in stock. The process, I'm going to get through data dictionary right here. And then after the report, logical versus physical mode. So I told you we would talk about this towards the end, and I'll show you your chapter activity. Again, you have logical and physical. The requirements of the, I said mode, I mean model, but the logical would give you an idea of how something done, and the physical would show the requirements that are needed to complete this right now. And then it would be sequenced in. So your chapter activity, I would like you to, well, I'm not there yet. I want to do this one last slide. The four model approach, you have a physical of the current, logical of the current, and then logical and physical of the new system. This has to be developed in order to understand. So now to the chapter activity. Would like you to do a decision table. I have started with you. Look in your instructions. I've started your first row. Your first row should look something like this. If you notice up here, you have 4 yeses and 4 nos. And then you'll have more items underneath that will change this up for a decision table. I would like you to read about decision tables and see what they mean. Very important. Decision trees, these are kind of fuzzy. Drag these off the internet. These are examples of decision trees, and you're going to be doing decision trees. You will take items from this and turn this into a decision tree. Here you can see the yes, yes, and you can see the yes, no, and so on and so forth right here. So this is an example right here. And with that, we'll be doing the chapter summary. Again, your process modeling. Again, it's very important that you understand in developing these models. The more time you spend on the front end is the least time you'll spend on the back end on doing this. You're doing DFDs this time. Again, you did those last week. Purposely held back that assignment in order to help you with that. And then we talked about the data dictionary and as a analysis tool that can be used to develop and maintain that. So another fast chapter. Hope you enjoyed that, and we'll continue to move. Good day.